Hello everyone, I am Gourav and welcome to my channel Code with GD. In this video, I am going to use the crypto library provided by Node and we will generate hashes. I will show you how to generate cryptographically secure random numbers and we will see how to encrypt and decrypt data. So encrypting and decrypting data can be used when, let's say, you require to store sensitive information in your database, like credit card information or some secret access key to access certain services. In that case, you can't directly store the credit card information or the secret keys in your database. Let's say your database gets hacked, then all the information goes to the hacker. So you need to encrypt the credit card information or the sensitive information in your database. For that, we encrypt the data. Now the data should be encrypted in such a way that when you require it, you are able to decrypt the data as well. So let's see how to do that. We will start from the basics of what the crypto library provides in Node, and then we will move on to encrypt and decrypt the data. So let's get started. We will be coding for this in TypeScript. If you are new to TypeScript, you can check out my TypeScript playlist. So let's get started. We will need to use the crypto library provided by Node. So let's add it to our package.json. So this installed my crypto library. Now that we have installed crypto, let's see how to generate random numbers. The crypto library provides us two ways to generate random bytes. The first is an async way where you call this and you continue with the execution, and whenever it receives a byte it will print the random bytes. The second is a synchronous way in which while the crypto library fetches for the random bytes, it will stop the execution there, it will fetch it and then provide the random bytes. So let me run this code and see what it prints. As you can see, it gave me two random bytes, this one and this one. Now the way crypto fetches random bytes is it uses something called entropy, which is given by the operating system. Whether you want to use async process to generate bytes or the synchronous way, that totally depends on your use case and it is a much larger discussion. Some prefer a synchronous way, some prefer an asynchronous way. If you use an asynchronous way, you don't know when you will receive the bytes. So let's keep that discussion aside. For the purpose of this video, I will be using the synchronous way, which blocks the execution to first generate the random bytes and then we will proceed. Let me comment out this. Now for the purpose of encrypting data, I need something called initializing vector. You can think of it as a salt which I add to my string to make the encryption process random. So I will rename it to IV. IV stands for initialization vector. And for encryption, we need it to be random every time. Now let's keep this aside and let's see how to generate hash. By the way, while printing the initialization vector, I had written toString because by default this contains a buffer. .random bytes returns a buffer of 16 random bytes and I wanted to print it in a more readable way, so I converted it into a string. Now let's move on to hash. So crypto.createHash is the function to create hash, and in this we specify the algorithm that we want to use to print the hash. I have used SHA1 and then .update. So this will contain my message for which I want to compute my hash. My message is code with GD and of course you should subscribe to it. And the last is .digest hex. So I want my hash in the hex format, hexadecimal format, hence digest hex, and then I print my hash. So let's see what it prints. So this is the hash of my message code with GD. Now if we use the same algorithm, we will keep on getting the same hash. It is deterministic in nature. Now crypto library supports a wide range of hash algorithms. It's not just limited to SHA-1. If you want to see what algorithms crypto supports, this crypto library supports, you can look at it as well. You can console.log crypto.get hashes, and crypto supports all of these hashes. You can use any of these. For example, let's say I use MD5 SHA-1. Let me comment out this. So this gives me a hash. So you can use any hash depending upon your use case. Now let's see how to encrypt our data. So let's say I have some credit card number which I want to encrypt and store it in my database. So I use let credit card is equal to, I don't know, I will just put a random number 9014. It will be a string 45922346. So let's say this is my credit card number, and similarly I will have a CVV which will be a 3-digit number, let's say 725. I want to encrypt both of these. To encrypt our data, we need a secret key. That secret key should be of 32 bytes in length. So let me define it. Now I know this string will give me 32 bytes, so it is safe to use this. In case my string is not 32 bytes or my initialization vector is not 32 bytes, my code will give an error. So make sure you always use 32 bytes for it. You need to store this in configs. Now comes the main part, to encrypt the data. We will encrypt our credit card information. Now in this code, crypto is our library, and create cipher IV will use the cipher algorithm mentioned here. We are using AES 256 CBC cipher, and we will use our secret key which is of 32 bytes, and we will use the IV which we had generated here. I will just copy it, and this will create a cipher for us. Crypto supports a variety of different cipher algorithms. To have a look at what algorithm it supports, you can console.log it. So these are the different ciphers that you can use. Now next part is to get encrypted message. So I have encrypted credit card information, and I will also have encrypted CVV. Alright, so once we have got our cipher object, we use update to put our secret message into this. Our secret message is the credit card information that we want to store. This UTF-8 is the input format. So this is in UTF-8 format, and we want our output, the encrypted data, in hexadecimal format. So we specify hex. Now we also add some extra thing at the end of our encrypted data, which is cipher.final hex. Now the cipher library tells us to do it, that's why we are doing it. Next, let's encrypt our CVV in the same way. I will just copy and paste. And this will be our CVV. Now we had used this cipher to encrypt our credit card number. We need to create a different cipher object to encrypt our CVV. Let's call it cipher for CVV. Yeah, now let's print and see what how our encrypted data looks like. Yeah, so this is our encrypted credit card number and this is our encrypted CVV. Now every time I run this code, I get a different encrypted result. This is because my IV, the initialization vector, is being generated randomly every time. Now we need to use the same IV to decrypt the information. For example, the IV used to encrypt my credit card number, the same IP will be used to decrypt this credit card number. We can't use the new IV to decrypt any other encrypted data. So we need to store the IV also in our database along with the encrypted data. So let's see how decryption will work. The code is almost same. Now in place of cipher we will decipher. We will decipher using the same algorithm, the same secret key and the same initialization vector. And in place of create cipher IV, we will have create decipher IV, and we will use the same object. Okay, so let me go through this piece of code. We create a decipher object. The crypto library provides a function create decipher using IV and secret key, and we can specify the algorithm that was used to encrypt the data. Now next line we call decipher update. Now we should have our encrypted credit card information, and our encrypted credit card information is in the format hex. Like this will be our input and UTF-8 will be our output. Since we had provided input in UTF-8 format, we need output also in the same format. Next, this is something that crypto tells us to do, to add this piece of code at the end. Similarly for CVV, we create a decipher IV using the same algorithm used to encrypt it. We have the secret key and initialization vector, and we mention our encrypted data here, and our input, the encrypted data, is in hex format, and our output is in UTF-8. While encrypting, our input was in UTF-8 format and output was in hex, so our resultant encrypted data is in hex format. Now for deciphering, we will give the encrypted data as input, which was in hex format, and we want data in UTF-8 format. So this is the reason. Now this is again something that crypto library tells us to do. Now let's print and see if we got our original card number and CVV. Okay, so this will be UTF-8. So this will be the output format, UTF-8. Now let's run this. Yeah, as you can see, we got the encrypted data as this, and this is the deciphered card number. Similarly, we have the deciphered credit card CVV. Let's run this again and see. So as you can see, every time we get a different encrypted data, but the deciphered data is always the same. This is because we are using different IVs to encrypt the data. Our secret key is same for all of these, which will be stored securely in our server configurations, and the IV will be stored along with the encrypted information or somewhere where you can relate that this IV was used to encrypt this particular credit card number. So that's it for this video. And Crypto is a very powerful library provided by Node, and you can do a lot of different things with it. I have attached the link of this code in the description below. Thank you for watching till the end. If you like this video, don't forget to hit the like button and share this video with your friends. Don't forget to subscribe to my channel Code with GD. Till then, happy coding. Bye bye.